Welcome to my breakout session on Spring Framework 6 and specifically infrastructure themes that are with us not only for the 6.0 release, but for the entire Spring Framework 6 generation. There is a lot of ground to cover, and some of it has been covered already in other sessions. So I'll take a deeper dive on a selection of specific topics that are of special interest, in particular to the core framework itself and to the value that the core framework can provide by integrating with ongoing platform innovation in the Java ecosystem. So we'll revisit some of the Java and Jakarta topics. We'll do a deeper dive on AOT into some of the approaches in the AOT space. And last but not least, we'll dive into virtual threads and the specific impact that virtual threads can have for Spring applications. So first things first, basically continuing from the baseline topic where, as always, Spring Framework 6 raises the baseline. It's a minimum requirement coming now for Java 17. To give you a bit of an idea of where we are, let's look at the context. How did we actually arrive at that decision? Spring Framework 6.0 actually got released against a state of the ecosystem where JDK 19 is already available. So JDK 17 may be the current long-term support release of Java, an ideal baseline for us, but there are actually 2 JDK releases in between already. And not only that, there's a next long-term support release of Java coming up with JDK 21 in September of 2023. So as you can see here in the timeline, Spring Framework 6.1 is actually going to be released against a state of the ecosystem where there will be a choice of 2 important recent long-term support releases of Java. And in particular, we will get some of the projects materializing, potentially going out of preview for the JDK 21 target here. So it's a very exciting state of the ecosystem that we're in, a state of the Java platform that we're in here. And with everything we do at Spring Framework and Spring Boot level, we mean to be the best possible citizens in a very timely fashion to everything that is happening here in OpenJDK and around OpenJDK. All right. Quickly going back to the baseline, there is a whole range of reasons why Java 17, JDK 17 is an important baseline for us. There's a lot of goodness in the language, say everything from text blocks to, well, the instance objects we really love for the framework code base. There's a lot of goodness in the core libraries that the JDK comes with. Set off, list off, those methods are really super convenient. There is a new, well, an important new member of the type system in the form of record types that are now first class in the JDK and are also supported at the Spring Framework level. And last but not least, we have the module system, all the impact it brings to the JDK, and all the new APIs that it brings for introspecting module arrangements, which are important for frameworks if they mean to be a good citizen for module-based applications. So this is empowering the framework, very much taking a perspective of the value that it brings to the framework code base. But of course, equally important, even more important, is the impact for applications. You are able to choose Java 17, even in combination with Spring Framework 5.3 and Boot 2.7. So a lot of this goodness is already available to you if you upgrade your JDK there. But there is additional value we can provide, optimizations we can provide, API service improvements we can provide through being on a Java 17 baseline ourselves. So a lot of this impact of these benefits, they also shine through to the applications, to the application code base. But a baseline is a baseline. It's only the minimum requirement. We are very much focused on JDK 19 now already. So we always mean to embrace the latest version of the JDK out there whenever we release. And we also introduce at least basic support for new JDKs as they arrive to existing Spring Framework maintenance lines. So JDK 19 is where we are right now, JDK 20 coming up very soon. And JDK 21, as mentioned, is on the horizon already as a next long-term support release. There's one specific recommendation I'd like to give here. Whenever you upgrade your Spring Framework release, your minor release, your feature release, like 6.0 to 6.1, please consider upgrading your JDK along with it. We really focus on this latest JDK, usually the latest LTS releases as well, but also the latest regular JDK release. And if you're upgrading some of your stack, consider upgrading your JDK along with it. Yeah, this is really the way to do it with the modern day release cadence that the JDK comes with every half year. The other baseline topic is Jakarta EE. And it's well known in the meantime that there is a namespace change, a quite disruptive namespace change. Everything that used to live in JavaX packages lives in Jakarta packages now. This is particularly important actually for the annotation types that you typically use in your application code base. So JPA, bean validation, those would probably have the largest impact. But for code that you can change, so code that you have access to and that you can recompile, it's a straightforward replacement. JavaX.persistence to Jakarta.persistence, JavaX.validation to Jakarta.validation, and you're done. It's actually harder for precompiled libraries and frameworks. So not only your application code, also libraries and frameworks, they all need to adapt, and they need to ship precompiled versions with support for the Jakarta namespace. So it's a bit of a disruptive step, as mentioned before, but it's working out nicely, not least of it all because the value proposition of this change is that those APIs are going to be actively maintained going forward, rather than being frozen at the state that Java EE8 was in. And there is at least one iteration delivered already. Fortunately for our timing here in Spring Framework land, we released Spring Framework 6.0 against Jakarta EE10, where Jakarta EE10 is already available, with some new features and some interesting adoption in the landscape out there, in the provider landscape. So let's look at the providers for a start. Might not be totally obvious, but there is a different mode of adopting those new APIs here. Tomcat 10.1, for example, immediately upgraded to Servlet 6.0, which is fine. It immediately delivers an Jakarta EE10 level web container for us. Tomcat 10.0 was Jakarta EE9 based, Servlet 5.0 based. So that change from E9 to E10 came in a minor release of Tomcat 10.0 to 10.1. And to add to it, Tomcat 10.0 got end of life already. So at this very point, if you'd like to use a production version of Tomcat with a Jakarta namespace, the only choice is Tomcat 10.1, Jakarta E10. There is no supported version of a Jakarta E9 aligned version of Tomcat at this point anymore. So there's a much quicker adoption cadence, which also means some of the API releases are going to be phased out rather quickly and superseded very quickly by the next iteration. So Jakarta EE10 is a reference example for this. It will happen again with Jakarta EE11 whenever it arrives. So Tomcat did it in a pretty special way. First time ever really for Tomcat. Jetty is a bit more traditional, but it's also a bit different. Jetty 11 is Servlet 5.0 based. Servlet 6.0 support will come in Jetty 12, but Jetty 12 will actually decouple itself from the specific Servlet version. So it's you'll have a choice of different Servlet API versions to use with Jetty 12, which is also setting up Jetty for the adoption of further Servlet releases down the line. So the providers really all readapted to the evolution of the Java EE, Jakarta EE APIs. Going forward here, it's different from the past. which also means that from a Spring perspective, a Spring application perspective, those providers come with certain API levels, certain APIs, and in certain versions. You have to take them as they come, right? If you want to use Tomcat 10.1, it chooses to use Servlet 6.0 as the API to talk to it. If you take Hibernate ORM 6.1, it suggests JPA 3.1 to be used with it, although it can be used with a JPA 3.0 jar as well. It's also a kind of interesting choice. The same version can be used, the same version of Hibernate can be used with two different versions of the JPA jar. So there's a bit of an inverted scenario now. Not necessarily API level first, and then you choose your provider. Rather, look at your provider, choose the latest ideally, and it comes with a certain API level. You'll just take that. That's the strategy that we choose for Spring Boot in particular going forward. We focus on the providers. They come with certain API levels. That's what's going to be used at runtime. For that reason, we prefer Jakarta EE10. Jakarta EE10 is really, first of all, comes with actual new features. First new features in those APIs since Java EE8, and that's quite a while ago. We also make use of some of those. Spring Framework 6.0, for example, auto detects the presence of newer API versions, as it always did. It does the same now. It supports EE9 APIs if available at runtime, but it auto detects the EE10 level. And for example, the WebSocket upgrade API immediately has a use case here, a standard protocol upgrade. For the first time ever supported in Jakarta EE10, finally. We can use this for every Jakarta EE10 compliant web server. So for example, Tomcat 10.1 or Jetty 12. For Spring Boot 3.0, where we actually manage dependencies, external dependencies in certain versions, we also decided to ship basically an EE10 arrangement with potential downgrades. So it's basically EE10 level, basically, but it's provider bound. So if you choose to use Spring Boot 3.0 with Jetty 11 is Servlet 5.0 based, you basically get an implicit downgrade to Servlet 5.0. For every other provider that you choose, we basically use the highest API level that provider is supporting. And as a minor note, there are compromises we have to make because of some unfortunate breakages between Servlet 5.0 and 6.0. It's not technically compatibility breakages in the signatures. It's more like old APIs having been removed, new API types having been introduced, and it's really hard for certain purposes to support both side by side. So we had to make some decisions there. Not many, but one example is the servlet mocks. Those are basically static mocks that you might use for testing servlet-based code. They are Servlet 6.0 based now in Spring Framework land. Which means if you want to test Servlet 5.0 based code, you can do this. You can totally do this, but you need to have the Servlet 6.0 API on your test class path for using the Spring provided servlet mocks. Last but not least, we are provider first in our approach here. So let's look at some of the common providers. Hibernate ORM, the common persistence provider chosen behind JPA when used with Spring. We actually keep supporting Hibernate ORM 5.6 with its Jakarta adapters. We recommend the Hibernate ORM 6th generation. So Hibernate 6.1 specifically is the latest feature branch. And that's also what Spring Boot comes with now. Also, worth noting, we support Hibernate ORM as a JPA provider. So it's not actually supported through classic Hibernate APIs anymore. It's JPA bound now. We have we keep having the Hibernate 5 classic API support, but it's basically phased out from there. We expect Hibernate ORM 6 to be exclusively used as a JPA provider, since Hibernate itself chose to rebase itself as a JPA provider. There is no really notion of an independent Hibernate API anymore, just JPA extensions. That's exactly how we support them now. And on a related note, for in particular for reactive stacks, for Webflex stacks, we have early support for Netty 5 in our core reactive support, but Netty 5 is not final yet, so it's early support only. And the baseline or the common version of Netty for production environments is still Netty 4.1x, but we are going to embrace Netty 5 as it is being released in final stages. And on a very common component of web stacks, of Spring-based web stacks, is of course checksum for JSON handling, JSON parsing, JSON rendering. We use checksum 2.14 not just as a feature upgrade, just because we can, but rather there's APIs in there, enabling APIs in there that we can use for certain purposes. So checksum 2.14 is really a good version to run against for framework providers with a few additional possibilities that we can optimize towards. All right, so much for hopefully not too much surprise in the approach that we're taking there. It is a high baseline, but it is really setting ourselves up for embracing the latest versions of the providers out there in the ecosystem, hopefully with further provider innovation immediately adoptable for Spring Framework 6 and Spring Boot 3 based applications. Let's move on to ahead of time. Ahead of time processing is a wide and deep space. So the notion of what we do in Spring AOT is clearly defined. It's taking a Spring application context, introspecting its configuration, and transforming it into a tighter representation, minimizing the use of reflection, and producing additional runtime hints with it. This is a pretty core functionality at Spring Framework level, which can be used for many purposes. Totally can be used for custom purposes, can be used for external tools. It's an extensible and flexible arrangement, as you would expect. It is, for some scenarios, such as GraalVM native executables, it is a mandatory step to take. So for some environments, it's an optimization. For other environments, it's a necessity. Of course, the traditional Java approach of building is basically compile, build your jars, deploy them. Here we are really asking for extra build setup to be involved. These build steps may take time, but more importantly, they of course add a degree of an additional layer, a degree of complexity to your build setups. We are aware of this. Of course, you can keep using traditional build setups. It's an opt-in area of optimization where you can choose to refine your build with certain steps in order to produce a more efficient outcome for deployment purposes. That's really the strategy, the direction that we see for Spring AOT overall. GraalVM native images, well covered in other sessions. I'll briefly look at it from a core framework perspective here. It's of course the key target of many of the AOT efforts here. It's coming with a strong closed world assumption. So not only do you need to lock down most of your Spring configuration, you also need to know the complete set of classes that you're running against. You need to have the runtime hints in a complete fashion. So you need to know every single point of reflection, every single resource that you're adding, every single proxy that you're asking the JDK to expose. So there is a really a complete understanding of the target environment and the needs of your application. In the build setup, it's basically coming right after the AOT step, right? An AOT processed Spring application can be fed into the GraalVM native image compiler. You arrive at a native executable. It's the very end of the build chain. We really want this to be seen as kind of a production target. You lock down not only the configuration of the application to quite some degree, you also choose a specific target architecture that you're building the native executable for. So that's really not meant for development even, or for any purposes in between. You might integration test those, of course, the native executables. But in development, you would use regular means of deployment and debugging. You might test your AOT processed application. You can easily do this. And we're also considering first-class support for other tools for enforcing the presence of runtime hints for reflection steps. There's ways to do this based on JVM agents. So we're not at the end of the tooling and the conveniences that we can provide for the development phase here. But fundamentally, native images take a long time to build. You would really only do this for integration tests and production targets usually. Of course, the benefits for production are really manifold. In particular, dramatically improved startup time, but equally important, significantly reduced memory consumption, a significantly reduced footprint. So there may be many reasons why you want to deploy a native image. It's not just about startup time. There are plenty of benefits combined, but you can only really take them as a whole, right? It's a bit of an all or nothing thing if you're building native images. And that's exactly where an initiative on OpenJDK side comes in, Project Leiden, which means to identify different variants of static images, which is the term that they are using. It's basically what GraalVM native images do in some way, where GraalVM native images are sort of the end of a spectrum, the strongest constraints, the strongest closed world assumption, the strongest benefits. And in Project Leiden, they mean to identify other points of basically other parts of that spectrum where you may have weaker constraints and still significant benefits attached. Project Leiden has yet to deliver. It's an ongoing effort, and we have to see what actually materializes out of it. It is very compatible in terms of the direction with the approach that we're taking in Spring's AOT arrangement. So whatever comes out of Project Leiden, whatever kind of potential for other approaches might emerge there, we really designed Spring AOT to be able to embrace variants of those approaches going forward, even if it is initially, as a reference case, are really targeting GraalVM native images very much. And another one worth mentioning is, here again, is Project Crack, which is also an OpenJDK submitted project. It is developed by Azul, and it stands for Coordinated Restore at Checkpoint, a different approach. So basically we're saying, let's stick with a regular hotspot JVM and excuse me, deploy a Spring application on the hotspot JVM. The idea is that you basically take such a regular deployment arrangement, you bootstrap it, you warm it up with some requests or some load tests or whatever you do to them initially. And then you take a snapshot of the state of the JVM, the state of the application in its warmed up phase, in its warmed up state. So basically with the JVM, all the code caches pre-populated. Ideally, the hot code paths pre-compiled already, pre-compiled with their most optimal representation. And then for further bootstrapping purposes, you would take that snapshot and start from there. So this is, of course, dramatically improving startup time. You basically don't go through the entire JVM bootstrap and warm-up phase. You rather start exactly where you want to be in terms of warm-up. It's dramatically improving startup time, but it is, for all other purposes, a regular JVM setup. So basically, no further benefits really. No footprint will be roughly the same, but it's a pretty simple and straightforward approach for taking a hotspot JVM and dramatically improving startup. It's adopted by AWS Lambda Snapstart already with a basic integration with the core crack API, where you get a callback for before the snapshot is taken and after the snapshot is being restored. This is not a necessity. For many applications, you can apply this approach without special support in the application or the framework at all. You basically just move it into a state where you can take the snapshot. The additional callbacks that are provided here that AWS Snapstart is also using is basically, if you know that certain resources should rather be stopped because you shouldn't have open file handles, open network sockets, you can basically do a stop step. Then the snapshot is taken, and then there's a restart step for this running application. It's to some degree it is a bonus, but if we can support crack-like arrangements, snapshot-like arrangements with some specific callback interaction, for example in Spring Boot, then we will do this as these approaches and these APIs become final. For example, stopping the Tomcat or Jetty server and restarting it when a snapshot is taken. So this is very much evolving, as you may already have noticed. There's a lot going on, and it's not quite clear to what degree all these approaches really will materialize. There's further stuff going on. GraalVM means to realign with OpenJDK, so releasing twice a year with every OpenJDK release, then only supporting the latest language level in these GraalVM releases. There's a new initiative called Project Galahad, which is about going further, where GraalVM technology is to be merged into OpenJDK proper. For example, the GraalVM JIT in particular, later on possibly even native image support itself to become a part of OpenJDK proper rather than an extra release that is just aligned with it. We talked about Project Lightning, which yet needs to deliver concrete specifications for other variants. And crack support, it's unclear in what kind of JDKs overall you'll be able to actually use this. It's very Linux focused initially. So we may see this in further offerings, even as standalone JDK offerings, but it has yet to materialize. So the key question is which of those approaches are going to really be well adopted in the mainstream. It very much looks like GraalVM native images will be right there right now in 2023. For other approaches, it has yet to be seen for which kinds of scenarios they are the ideal choice. All right, so much for a bit more analysis of the IoT space out there. We'll move on now to another topic, to virtual threads. Project Loom, OpenJDK's Project Loom, is introducing a notion of virtual threads to the Java platform. It's currently in preview stages, but really expected to go out of preview in the near future. Virtual threads as a lightweight threading model within the JVM have a lot of potential benefits that they can bring, not only being lightweight as in the footprint of the thread itself, but also in just a different level of scalability to be in reach for traditional thread-bound programming models. The general idea is keep your threads, your operating system threads busy. So never block them. So the operating system threads would always be available for actual processing. Virtual threads are a kind of variant of a thread that the JDK introduces, that the JVM introduces, that the JVM manages itself. API-wise, you won't see much difference. You can ask a thread whether it's virtual. You can choose to create a thread as a virtual thread. It's largely transparent to application code and also library and framework code, as long as the alignment of things to do and not to do in a virtual thread scenario has happened. There's a bit of alignment to do. It's, for example, not using synchronized blocks around I/O operations. So there's a bit of a sort of following general good practices in order to be naturally compatible with virtual thread scenarios. We were pretty far along there, but there's, of course, many database drivers and etc. out there where some improvements can still be made. It's not totally a block of a usage in a virtual thread scenario. It just means that you won't get the full benefits of virtual threads if some of those practices haven't been followed in libraries or frameworks that you're using. But under the assumption that your stack is ready for virtual threads, what can you do with it? It's mostly about web applications. It's the reference scenario. It can be used for many purposes, but let's look at web applications first. Mostly talking about servlet container bound web applications with server callbacks and blocking data store operations. So Spring MVC on the servlet container doing JPA, JDBC data store interactions is a reference case for this. Traditionally, there's a thread pool with operating system threads that the web server, the servlet container, is using for dispatching to your application code, to your handler methods. Replacing those with lightweight virtual threads for each task, for each callback, gets rid of the pooling part of it for a start, and can increase scalability quite significantly. There can be a much higher number of virtual threads coexisting within the JVM than you could ever have with operating system threads. which in particular makes sense if most of your threads are expected to be blocking, waiting for the database to return its data, waiting for some interactions with other services through HTTP. If that is a very common scenario for your handler threads in a servlet container, then virtual threads are worth considering. There might be other bottlenecks. So virtual threads are an enabling tool in the toolbox that you can choose to apply. But of course, then you might find in your connection pool actually limits concurrency by how many connections it can provide. You need to tune the connection pool accordingly. There may be other factors involved that effectively limit concurrency. There's also other factors that you can choose to apply in order to limit concurrency, because in order to limit access to the database, for example, virtual threads totally let you do this. But fundamentally, database-driven web applications, typically servlet-based, SpringMVC-based JPA interactions, is a perfect candidate where you would consider the use of virtual threads. And that's also where we expect from a Spring perspective out-of-the-box options for virtual thread setups. In the web servers themselves, in Spring Boot, when it embeds those web servers, this has yet to materialize. Once virtual threads go out of preview, we mean to provide first-class configuration options for common scenarios that we identified here. But talking about scenarios, let's not just exclusively look at web applications. Virtual threads can be used for any purpose where you use explicit threading in Java. So it's a mix and match approach. You can choose to use them for some purposes and keep using operating system threads for other purposes, very much depending on what's actually happening in those threads. So for another scenario, let's look at messaging. Messaging is interesting because it really depends very much on the kind of message broker setup that you have. Some message brokers just dispatch to your handling code, where they could use a virtual thread for that dispatch. If your handler code reaches out to databases, to data stores, and performs blocking operations, might be a good idea to do this. For Spring's JMS message listener containers, there might be even more value to provide here because it's using listener threads that basically spend most of the time waiting for incoming messages, in particular if not a lot of messages come in. So those listener threads could also be virtual threads and not a pool of or an arrangement of operating system threads. We have to experiment with this. If there turns out to be good value, it's basically a choice even as a default, or at least as a convenient first-class opt-in choice. For cron triggers, for scheduled methods that dispatch back to your application code, it's as with everything here, it's very dependent on what your callback actually does, your application implementation of the handler method actually does. If it just spends a few CPU cycles, some calculations, some cache retrievals or cache updates, you might not see any benefit with virtual threads, because virtual threads only really provide benefits when you have some blocking involved. So purely CPU-bound handlers, basically no benefits expected. But if you have blocking data store operations, even there, then it's very much a good idea to consider virtual threads. And we are seeing a lot of interest, excitement about virtual threads, very high expectations. So we'll get to that in a moment. But before that, I'll explore a bit of an elephant in the room. The topic of virtual threads versus reactive programming. It's kind of virtual threads is a scalability option, an emerging scalability option for traditional thread-bound code, imperative code, like servlet container code, SpringMVC basically in the Spring Web Stack. So reactive programming, as with Spring Web Flux for a reactive web stack, of course also has a strong scalability aspect to it. You might choose to build a reactive service primarily for scalability reasons. And that is fine. Now with virtual threads, you also get a scalability option, potentially with similar scalability to be reached for Spring MVC bound traditional imperative code. That is also fine, but of course it might take some incentive away from choosing reactive programming just for that purpose. And the important part is just for that purpose. Reactive programming has other benefits to it. It is essentially a stream-based processing architecture. In particular, if you have a non-trivial arrangement of longer running streams, multiple streams of processing, then there can be significant benefits out of the programming model or out of the stream-based processing arrangement in the stack. So you would choose reactive programming certainly for programming model reasons, for stream-based architecture reasons, just not primarily for scalability anymore. That's the way we are seeing this kind of duality. And we keep supporting and evolving both variants of the stack. So we basically want to let Spring MVC get empowered through virtual threads. And we also keep pushing for the reactive stack kind of maximizing its potential, reaching its potential. There might even be combinations, the use of virtual threads in reactive kernels. That's a bit of a separate topic. We're really primarily seeing Spring MVC with virtual threads as kind of a scalability arrangement on one end and a reactive webflow stack on another end, and different programming models, different processing characteristics attached. Make your choice. We provide both of them first class to you. So, wrapping up on virtual threads, there are high expectations in the community out there. So to the degree where it will be hard to actually meet them in practice. Virtual threads can provide higher scalability, in particular for server-based web applications, Spring MVC applications, and we totally recommend exploring that potential. Even against the previews right now, just a little bit of configuration setup can get you there for basic purposes, but even more so when they're out of preview and have first-class configuration support. Please explore that potential for each individual application and service that you're building. There might be many interesting things to do with virtual threads. Don't see them as an all or nothing, black or white choice. You can mix and match the arrangements, use them for certain purposes, but not others. You can also just keep targeting the same concurrency level, but you mean to arrive there with a smaller footprint at runtime. And virtual threads can also be totally a tool in the toolbox for that goal. Same concurrency level, but with primarily using virtual threads, you'll get a reduced memory footprint in particular. It's all about the goal of maximizing the use of the resources that you have. It's very much an architectural challenge to embrace them for your specific scenario, your specific architecture. Last but not least, virtual threads are supported in GraalVM native images as well. So even if you're deploying as a native image, you can choose to use virtual threads. You can choose to use virtual threads in your code, and they are going to be translated to native image matched virtual threads. The potential for optimizing the footprint of our applications going forward with the tools at hand here is certainly great, but don't be too disappointed if the benefits only show to a limited degree initially. You need to tweak all sorts of knobs, check your connection pool, check other potential bottlenecks in your system in order to increase the impact that virtual threads can have. So it's definitely not just a flag to turn on. It is an architectural effort to embrace virtual threads for your specific scenario. All right, quickly returning to the timeline here, because remember, virtual threads are in preview. JDK 20 has them in JDK 19. JDK 20 has them in second preview, and for Spring Framework 6.1, that time frame, in JDK 21, there's at least a chance of maybe a further preview or them going out of preview. We'll see. If they remain in preview for longer, we certainly recommend exploring the potential of virtual threads against the preview. Preview just means that the APIs may change, that some details may change, but fundamentally they are, whether you get the basic benefits of virtual threads, you can explore already, even against the preview in JDK 19 and 20. All right, that's basically the end of my deep dive on these couple of topics. Spring Framework 6.0, of course, is our current branch. 6.0x releases coming roughly every month, primarily targeting JDK 17 for production at this point. Keep in mind that Spring Boot 3.0 ships a feature release every half year, so Spring Framework 6.0x is actually the foundation for both the current Boot 3.0 release and the upcoming Boot 3.1 release. Spring Framework 6.1 then again is going to be, according to the plan, the foundation for 2 Spring Boot releases. 3.2, basically co-released in November 2023, and then also the subsequent Boot 3.3 release. All right, so Spring Framework 6 as a generation is very much here at the start of that generation. Spring Framework 6.0 and Spring Boot 3.0 provide everything you need to perform an initial upgrade. This initial upgrade can really put you into a position where you're able to embrace all the further innovation that's happening in Spring, in the Java platform, in the Java ecosystem. Once you're on this new baseline in particular, once you're beyond this disruptive Jakarta namespace change, you're totally ready to explore the potential that some of these ongoing infrastructure efforts can deliver right now or in the very near future. So we strongly recommend putting yourself into that position for a start and then taking it from there. So enjoy the upgrade, do it at your own pace. We keep maintaining Spring Framework 5.3x for quite a further while. So it's a choice that you're making when you're upgrading. You don't have to worry too much about adopting anything new, really. You can initially just perform an immediate upgrade to Spring Framework 6 and Spring Boot 3, keep everything intact, and then selectively adopt some of those newer features, some of those new infrastructure offerings going forward at your own pace. So that's all I had for you today. As I said, enjoy the upgrade, and thanks for listening.